So now we're going to be looking at finding cosecant, secant, and cotangent of these angles, which basically is just one more step where we're going to have to find the regular function and then flip the fraction. So if I see secant of 120, I'm going to come back to this at the end, but I'm going to be finding the cosine of 120 because we know that cosine and secant are reciprocals. So I go through my process, I figure out what quadrant I'm in, 120 is in quadrant 2, cosine is negative there, my reference angle is 60, so this is the negative cosine of 60. On my chart, cosine 60 is 1/2, so I get negative 1/2. And remember that's not actually my final answer because I'm trying to find the secant of 120. So I'm going to take this answer and flip the fraction over, keeping the sign, whatever the sign is, positive or negative. I'm going to keep that, so that is negative 2. The cosecant of 120, so we have the same angle, same reference angle, but this time we're going to be working from the sine of 120. So when I'm over here, I draw same reference angle. We are in quadrant 2, where sine is positive. So this is going to equal the positive sine of 60, and sine of 60 is radical 3 over 2. So when we find the cosecant of 60, that's going to be 2 over the square root of 3. If we rationalize the denominator there, we're going to get 2 square roots of 3 over 3. So this is probably, if you want to work through the rest of these and then come back and check, you probably might be ready to do that. So secant is the reciprocal of cosine. 7 pi over 6 is in quadrant 3. Cosine is negative in quadrant 3. Remember, our reference angles we can always just use, we're finding the distance from pi. So this is going to be 1 pi over 6, and we set negative. So the cosine of 30, cosine of pi over 6 is radical 3 over 2, and we need to be negative. So over here, my secant value is the same exact number except for reciprocal, so we flip it over. And already from up here, I know how that simplifies. Right, I had another 2 over radical 3, so I get negative 2 square roots of 3 over 3. The cotangent of pi over 4, 5 pi over 4. So we are again in quadrant 3. Our reference angle is pi over 4, tangent is positive in this quadrant. So I'm finding the tangent 5 pi over 4, which is equal to the positive tangent of pi over 4, and the tangent of pi over 4 is 1. So when I flip that over, I still have a 1 over 1 to 1 over 1. For any of these quadrantal angles, there is a little bit of a layer of something that we do have to talk about. So pi is a quadrantal angle. The point here is negative 1, 0. So the tangent of an angle y over x would be 0 over 1. Sometimes that there's a benefit to doing it that way, so we could say tangent of theta equals y over x, so 0 over negative 1, which is 0. So this is the reciprocal of that, which is 1 over 0. But we almost kind of got a different fraction. So that does work sometimes, but the better thing to use is knowing that cotangent on these is the reciprocal, which is x over y. I'm going directly from the point. So x over y, negative 1 over 0 is undefined. We would get that if we had used this, and we had done 1 over 0 from this, but you see it's a little different, and sometimes I can get this one. So we're directly from the points for these quadrantal angles. Secant of pi. So the cosine of pi is the x value, which is negative 1, So this is 1 over -1, which is -1. You can go directly from the point again, 1 over x, because secant is 1 over x. So I'm going to start to use that method of just thinking about from the point from now on. So here I do need to get a coterminal angle first. So if I have -pi/2 plus 2 pi, that's plus of 4 pi over 2. So this is 3 pi over 2. So this equals the cotangent of 3 pi over 2. When I am on the graph, 3 pi over 2 is down here. The point is 0, -1. Cotangent is x over y. So we get 0 over -1, which equals 0. If I had started from tangent, tangent is undefined. So I have to really work from that point, because if I think it's undefined, maybe I think everything related to it's undefined. So as I said, better to work from the point for quadrilaterals. So this one, 5 pi over 2, I'm going to subtract 2 pi in the form of 4 pi over 2, and get pi over 2. So this is the cosecant of pi over 2. I'm going to put my point down at pi over 2, which is 0, 1. Cosecant is 1 over the y value, 1 over sine, so it's 1 over 1, which is